Yes, ma'am.
All right. So are you able to see the screen?
Yes, ma'am.
Yes. So in last lecture,
Yes,
we
ma'am.
have seen some of the Boolean equations, right? So we have discussed in last lecture some Boolean equations, which,
Mother,
yeah, what?
no, ma'am.
All right. So I just found some other book in which the entire detailed things are given. So I just made PDF from that book, and we are going through this. All right. That previous PDF which I showed you, that does not contain all the information. So just we'll go through this. This is again the same thing. It's just that the detailed information is given in this. First is your what? It is a Boolean enzymes. So what is Boolean enzymes? So basically, you can call it as a operators. Which operators you are using while solving the Boolean equation is called as Boolean enzymes. See here, first of all, the operators in Boolean algebra are slightly different than the conventional algebra. So in algebra, which operators do you use? Addition, subtraction, multiplication, division, the signs of all them, right? But in case of Boolean algebra, what we are going to do, we are going to use basic gates and the following operators. So there are specific operators which are given to the system, and we are going to use the basic logic gate. So first operator is nothing but your dot sign. What is the dot sign indicates? Can anybody tell me? In last lecture I told you.
Multiplication.
Right.
Multiplication.
Dot
Multiplication.
indicates multiplication, right? So if I just write A dot B, what does that mean? A is going to multiply with the B, right? So the dot sign, which is also expressed as cross. So आपण multiplication साठी cross वापरतो, right? Dot sign is also expressed as a cross, indicates the logical product of two terms. Product is nothing but your multiplication. Multiplication of two terms, A and B. See here, A and B. So in our logic gate concept, we use AND gate for multiplication. Am I right? We are using AND gate for multiplication. Yes or no?
Yes, ma'am.
Yes,
We
ma'am.
have seen all the logic gates and the function and the truth table and the expression for the each and every logic gate. Correct. Now see here, the logical product of the two terms A and B is expressed as A dot B. So if I want to represent the product of A and B, how will I write it? A dot B, or simply I can write it as A cross B, right? And it is read as A and B, right? How to read this? A and B. Why and in between? Anybody?
Multiplication.
Correct. So
Multiplication.
AND gate is a logic gate which we are using for the multiplication. The inputs A and B are also said to be ANDed. So input A and B are said to be ANDed. ANDed म्हणजे काय? Multiplication झालेलं, right? The second operator is your plus sign. Okay. Which gate we used for addition?
Or
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 gate,
gate.
right? Simply the OR gate we are going to use for the addition of two variables. Correct. The plus sign indicates the logical sum of the terms. कौन बोलता है? कौन बोलता है? बोल नका. Okay, so plus sign indicates the logical sum of two terms. So whatever the two terms you are going to have, if you want to add them, so what you are going to use? A plus sign basically. For an example, A plus B represent the logical sum of A and B. Right, and it is read as A or B. Why or again? Because OR gate is used for the addition. Correct. The inputs A and B are also said to be ORed. Correct. Here इथे काय म्हणणार आहे आपण? The inputs A and B are said to be ANDed. Right. Here input A and B are said to be ORed. Correct. Now next and third operator is what? It is your overbar. Now in case of Boolean expression, overbar is what? If I see this A and if I just wrote like this, so what does that indicate? It is called as A bar. Right. What does that indicate? The complement or the negation of the A. What is the function of NOT gate?
Inversion.
Inversion, right? Simply this is nothing but also your inversion. Whatever the value of A you have, suppose A is equal to 0, right? So how do we write this? 0 bar. And what is the answer of this?
1.
1, right? It is nothing but simply inversion or complement, you may say. Correct. So overbar is nothing but it is a sign that indicates the term which is overbar are to be complemented. So whatever the variable you are going to have, if there is a overbar on that variable, then simply you have to complement that variable. What is complement? Again, inversion. If A is 0, then you have to complement it and the answer will be 1, right? For an example, it is given, say, A bar represent complementation of the term A, and it is read as not A. You can read it as not A, right? Why not? Anybody?
Because of not get inversion.
Right. Not get is used for the inversion. That is why we can read it as A, not A. Right. Now see, these are the three different variables. First one is your dot sign, second one is your plus sign, and third one is your overbar. Correct. These are the three different operators we are going to use while solving Boolean algebra equations. Understand, everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
Right.
ma'am.
Now, next is the Boolean addition and multiplication. So basically, there are some separate rules for the Boolean addition and multiplication. Correct. So what are those rules? We have to see and we have to implement these rules while doing an actual addition or multiplication of the Boolean equation. Correct. Now see, for addition, what is the rule? 0 plus 0. What is it? What will be the answer? Ideally,
Everyone.
0.
0 only. Correct. 0 plus 1. If I add 1 and 0 together, what will be my answer?
1.
1.
1. 1 plus 0 again 1. Now here see
1.
1 plus 1. In case of OR gate, आपण काय लिहायचो? What was the answer of 1 plus 1 in case of OR gate?
0.
0.
0. But the complement we used to write as 1. Correct. 1 plus 1 0. But the complement is the carry is 1. Right.
1.
So this is how the 1 plus 1 is equal to 1. Everybody understand? We have seen this in last lecture. It's just a revision. Right. That is why I'm going so fast. Yeah. Okay, so Boolean addition is the same as that of OR, right? We have seen this. Whatever is the operation of your OR gate is used for addition only. And these are the basic rules for the Boolean addition. Now see, notice that it differs from a binary addition in case where two ones are added. So in case of OR gate, 1 plus 1 we used to write as 0. Right, but here we use 1 plus 1 is equal to 1. So this is what is an exceptional case. See, it is differ from a binary addition in the case where we add two ones. Right, two ones का है तुमसे 1 plus 1. Understand?
Yes, ma'am.
Good.
Yes,
Now
ma'am.
next one is your multiplication. Multiplication is a straightforward multiplication. If you multiply 0 with any number, the answer will be 0. This is nothing but your first three cases. If you multiply 0 with any other number, the answer will be 0 only.
0.
Am I right?
Yes, ma'am.
Yes. Now, if I'm multiplying the variable with itself, if I'm multiplying 1 with the 1, answer will be 1 only.
1.
Right? This is nothing but the rules for multiplication. Right? And next one is your Boolean Boolean multiplication is the same as that of your AND operation. AND is nothing but again your multiplication. Right? Next is your complementation in the Boolean algebra. So I told you this earlier. If there is a 0, the complement of this is nothing but your 1. If it is 1, the complement of 1 is also always equal to 0. Right? Which gate is used for complement?
Not.
Not.
What is the symbol of NOT gate? Am I right?
Bubble.
Right, there is a bubble. Don't miss this bubble. If you are drawing like this only, then it is not a NOT gate. It is called as a buffer. Right? If there is a bubble, then and then only it is called as a NOT gate. Correct?
Yes, ma'am.
Next, these are the rules and laws of Boolean algebra. So we have seen here, whatever we have seen just right now, these are the operators. Okay, dot sign, plus sign, overbar, and this is nothing but Boolean addition and multiplication. Now, which are the rules and laws we have to use while dealing with the Boolean algebra? First of all is your law of intersection. This everything you have seen in your 12th standard. Am I right or no? Intersection
Yes,
law,
ma'am.
commutative,
Yes,
additive,
ma'am.
all those laws. We are just going to repeat all those laws, and we have to see the logic diagram for each and every law, right? So what we have to do, intersection law everyone is aware of, but we have to implement by using our logic gate. It's just the different thing, right? Now see, first law is of your law of intersection. What is law of intersection? If you are multiplying any variable with 1, okay, so I already told you the value of variables in case of digital, that should be either equal to 0 or equal to
Or
1.
1.
Right? Now, which variable I used in this equation?
A.
A. The value of A is going to be either 0 or 1. Am I right?
Yes, ma'am.
Yes, ma'am.
Now, let's consider both cases. If I just put A is equal to 0 in this equation, what will be my equation? 0.1 is equal to whatever my answer is, the 0,
0.
0.
right? And if I just consider A is equal to 1, what will be my equation? 1.1
1
is equal to
1.
1 only,
1.
right? Simply what happens here, we are just multiplying the variable which we are considering with 1. Right? So any variable is multiplied with 1 will give you the answer is equal to that variable only. Right? Everybody understand
ma'am.
this?
Yes,
Yes,
ma'am.
ma'am.
Right.
Yes, ma'am.
Now what we have to do, we have to implement this law of intersection by using a logic gate. Which logic gate I need to use here?
And
Why?
And negate.
Why to
Or.
use AND gate, not to use OR gate? Why should I
Because
not use?
multiplication is in
Because
AND.
multiplication is taking place.
Right, we have to multiply two digits, two numbers, right? That is why we are going to use a NOT gate. Simple, right? The function of NOT gate is just to multiply the given inputs. So what are the inputs we have?
Ma'am,
A
and
and 1. What?
it is an AND gate.
What I said there? I said OR?
Not.
Okay. Sorry then. So we are going to use AND gate here, right? Whatever the inputs AND gate have, AND gate is going to multiply these two inputs and going to produce the output. So what is the first input we have? A. What is the second input we have? 1. Because see here, it is clearly written. We have to multiply A and 1. A dot 1. What does that mean? We have to take the product of A and 1. So A and 1 will be your two inputs to your AND gate. And what is the output? A. Now, if you put A is equal to 0, so 0 into 1, answer will be 0. If you put A is
0.
equal to 1, 1 into 1, answer will be 1.
1.
Correct? Next, see here, if so this thing is nothing but the explanation which we saw here, right? The second law is nothing, the second type of your law of intersection is A dot 0. Right? What does that mean? If you are multiplying 0 with any variable, the answer will be
0.
0. We have seen this here. If you are multiplying 0 with any other number, if you multiply either 0 with 0, 0 with 1, then the answer is going to remain 0 only, in simple words. Again, the same thing we have to implement by using a logic gate. Logic gate here I'm using AND gate. Why? Because there is a multiplication. As simple as that. Right? Any doubt in this?
No, ma'am.
No, ma'am.
Great. Now see, the next law is your law of union. Correct? What is a law of union? If you are adding any variable with A, what I'm saying is if you are adding any variable with A, 1, sorry, the answer will be 1 only. Why? Because the value of A is going to be either 0 or 1.
0 or 1.
If I add 0 with 1, what will be my answer?
1.
1. If I add 1 with 1, what will be my answer?
1.
1. Here 1 only, right? So no matter what is my variable, what is the value of my variable, if I'm adding that variable with 1, the answer will be 1 only. Correct? Here which gate I used?
OR gate.
Why?
Odd gate.
Why?
Because OR gate takes place as addition.
Correct.
Addition.
Because we have to perform an addition operation here, right? And for addition we are using OR gate.
OR
Right?
gate.
This is nothing but your law of union. This is the first law of union. The second law of union is A plus 0. If you are adding any variable with the 0, the answer will be that variable only. We'll see this. How? The value of A is going to be either
0 or 1.
correct. If you are adding 0 with the 0, what will be my answer?
0.
0. Right. If I'm adding 0 with the 1, what will be my answer?
1.
1. So whatever is the value of variable you are considering, that is nothing but your output. See here I consider A is equal to 0, my output is also 0. If I consider A is equal to 1, my answer is also 1.
1.
Right? And again to implement the addition, same gate I'm going to use, which is OR gate.
OR
Clear?
gate. Yes, ma'am.
Yes.
Yes, ma'am.
Next one is your law of tautology. What is law of tautology? If you're multiplying any variable with itself, right? If you have a variable a and if you're going to multiply that a with a only, what does that mean? If I have a is equal to 0 and if I multiply 0 with the 0, what will be my answer?
0.
0. If I have a is equal to 1, if I'm multiplying a 1 with the 1, the answer will be 1.
1.
So whatever is the value of a or whatever is the value of variable I'm considering, the answer will be going to remain as same as that of
As it
variable.
is.
Right. Again, there is a multiplication in between. Dot represent multiplication, right? For
Multiplication.
multiplication, you have AND gate.
And gate.
Clear? Next one is the next law of tautology is addition. If you are adding any variable with the same variable, the answer is again going to remain same variable.
As
How?
it is.
See, 0 plus 0.
0 plus 0.
Answer will be
0.
0 only. 1 plus 1.
1.
Answer will be 1 only. Same thing. Correct. And to represent this by using logic gate, I used OR gate. Why? Because there is a plus sign. Plus sign represent addition.
And.
It's not AND gate, it is a OR gate.
OR
See
gate.
the difference. This is the AND gate and this is nothing but your OR gate.
OR gate.
Okay. Next one is your law of complement. Now, what is law of complement? It is, first of all, what is complement? It is represented by a over bar. Am I right? And over bar is nothing but complement. You can call it as A bar, right? A bar dot A. What should be the answer? Consider the values. Don't look at this. Okay, consider the value. If I consider A is equal to 0, okay, my initial condition is what? A is equal to 0. What is my A bar?
1.
1.
Dot. Dot with what? A. What is the value of A? 0.
0.
Right? If I am multiplying 0 with 1, what will be my answer?
1. 0. 0.
1. 0. Right? So if I'm multiplying any variable with its complement, the answer is always going to remain 0. Try to understand the thing. If I'm multiplying any variable, okay, so this is what is my variable, and if I'm multiplying that variable with its own complement, okay, so answer will be always equal to 0 in that case. Right? Consider second
Means,
case.
ma'am,
Bol.
A bar means the given value, we have to make it inverse. That's it.
Right. Yes. So we have considered the first scene in which A is equal to 0, right? We are considering a second example where A is given as 1. Now, what is the complement of 1 here? 0, right? Complement of 1, that is A bar is equal to 0 dot.
0.
What is A? 1. 0 into 1 again? 0.
0.
So what is the thing if you are multiplying any variable with its own complement? Right, the answer is going to remain 0. See, simple, eh? You are using any variable and complement of that. If that variable is equal to 1, the complement will be 0. If the original variable is equal to 0, complement will be 1. So no matter what you are going to do, the value is going to remain 0. X 0 असणार आहे तुमचा, right? And if you are multiplying that 0 with the another one, the answer is going to remain 0. Yeah?
Yes, ma'am.
Everybody understand?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now next law of complement is for addition. A plus A complement, or you can say A plus A bar, right? Now again the same strategy we are going to use. It's just that the operation is different. Here we multiplied it, here we are going to add it. Again, same, consider A is equal to 0, first case. Okay, simplify this equation. What will be the values? Tell me the answer. A, what? Just tell me this. If I consider A is equal to 0.
Plus 1.
Correct.
0
0 plus
1
1.
The answer will be
is equals to
1.
1.
Now consider A is equal to 1.
1 plus 0 is equals to 1.
Right? The same answer we are getting, no matter what is the value of variable A. Correct?
Yes, ma'am.
So this is nothing but your additive law of complement. You are considering complement and you are adding that complement with the original variable. And in that case, the answer is going to remain 1 all the time. Right? We have two conditions only, either a is equal to 0 or a is equal to 1. And both the cases we have seen. In both the cases, answer is your 1. Correct?
Yes, ma'am.
Yes. Now next is your law of double negation. That is nothing but, see here, a, if I just consider a bar and second bar, right? What does that indicate? It is a double negation. You have used this sign for negation in your 12th, am I right?
Yes, ma'am.
Yeah. But
Dash
here
and
for negation, we are using a over bar.
double
And
bar.
double over bar, nothing but is the original variable. Now see, we'll prove this. A double bar we have. What is the, which is the logic gate we are using for the complement?
Yes, ma'am. Not.
Not.
Logic, right? Not gate, right? So see here, first not gate we have drawn. Now we have double complement. That is why we have to draw 2 times not gate. Am I right? If it is like
Yes,
a
ma'am.
bar, then in that case we will draw a single not gate. But we have a double bar. In that case we have to draw 2 not gate. Correct? Yes. Now
Yes, ma'am.
consider a is equal to 0. Here if a is equal to 0, what is the output at this point?
1.
1. Now that 1 is going as an input to this NOT gate, right? What will be the output at this point? 0. Right? So whatever is the input we are giving, we will get the same output. Right? Now consider a is equal to 1. If there is 1, what will be the output at this point?
0.
Right? If there is a 0, what will be the output at this point?
1.
1. Right? So as you can see, whatever is the input we are providing, we'll get the same output. So double complement or double negation indicates the original variable again. Getting?
Yes, ma'am.
1. Yes, ma'am.
Okay, good. Next one is your law of commutation, right? Next one is your law of commutation. Now see, what is that? A dot B, which equal to B dot A. In simple words, if I just write A dot 1 dot 0, which is equal to 0 dot 1. Is that true?
Yes, ma'am.
Yes, in simple words, like there is no need of proof for this, right? If you are multiplying any two variables, so you consider in general 2 into 3 and 3 into 2, the answer is going to remain same, right? The same strategy we are going to use here, but it's just that we have value of variable either 0 or 1. That is why we are considering 1 into 0, which is equal to 0 into 1. The answer is same only. That is nothing but your law of commutation. Multiplicative law of commutation. Correct? See here, again there is an addition. That is why I used a AND gate. What are the inputs? A and B. Output will be A dot B, because the function of AND gate is to multiply the input. Right? That is why I'm getting output is equal to A dot B. That is equal to, exactly equal to, triple times this line is indicates you're exactly equal to. Right? That is exactly equal to B dot A. Why? We have seen here. Correct? Is this clear to all? Or no?
Yes, ma'am.
Yes, ma'am.
Clear.
Yes, ma'am. Yes,
Next one
ma'am.
is your additive law of commutation. Right? Again, the same thing. Instead of dot, we are using plus sign. Correct? A plus B is exactly equal to B plus A. It's simple as that. Right? If I consider A is equal to 0, B is equal to 1. So 0 plus 1, what will be my answer?
1.
1.
And
1.
here, B plus A, that is 1 plus 0. What will be my answer?
1.
1.
1. So in both the cases, output is same. That is what it is, law of commutation. Right?
Yes.
It's
Yes,
just that we
ma'am.
have two continuous lectures. Hazer lecture expires, so you have to join the second link, which I already shared to you. Right? Yes or no?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Law of association. Next law is your law of association. Now see, what is that? The law of the associative law of addition for three variables. So this is the law of addition for two variables. Now the law of association indicates the addition of three different variables. A, B and C are the three variables we are using. Now we have to prove that A plus B plus C is equal to A plus B plus C. Right? How to prove this? Again, simple, by using your logic diagram. What is logic diagram? The diagram which you are drawing by using logic gates. Try to understand the things, right? There might be a they may ask the question like, what is logic diagram? What will be your answer? Hmm? What is logic
The
diagram?
diagram
Hmm?
which is drawn using
Drawn?
logic gates.
Correct. In simplest word, the
Using
diagram which is drawn by using a logic gates.
Logic gates.
Right. What is the equation we have here? We have to draw A plus B
Plus
first. How to draw A plus B?
by
two
using an or gate.
and gate.
OR gate. Right.
Or
So
gate.
OR
Sorry.
gate we have here A plus B. It's just the thing we have to draw. A plus B. Simple A, B, two inputs, OR gate addition. The output of this gate will be A plus B. Correct? This is what you have. Now you have to add this entire thing with C. Try to understand what we are going to do. We have to add this entire addition again with the C. Correct? So A plus B I am already having at this point, and C is the next variable here. Correct? If I use again one OR gate, then what will be the output of this OR gate? A plus B and plus this C. Getting?
Yes, ma'am.
Yes, ma'am.
Yes,
It's
ma'am.
simple.
Yes, ma'am.
Just see, look at the equation which you want to implement by using logic gate. What is that? First, your in first bracket, what you have? A plus B. How to draw that? Using simple one OR gate, A and B. So output of this OR gate will be A plus B. What is the next thing I have to draw? I have to add C into that. So C is my next variable. A plus B I'm already having here. So if I just use a single OR gate, the output of this OR gate will be A plus B plus this C. Correct? Output at this point. Right?
Yes, ma'am.
Okay. Now, which is exactly equal to what we have to prove? A plus B plus C. Now for this, what I have to draw? Just look at the equation and then tell me.
First A and first output is A and second output
First
is
you have
B
to
plus
solve
C.
the bracket. First you have to solve the bracket.
First B plus C and then A.
Correct. First of all, I'll implement B plus C by using a single OR gate. Here you're my B plus C. Okay, B, C, two inputs, output will be B plus C. Why? Because the OR gate is there. Right. Now what I need to add? A. A is my next variable. If you draw that A on this side, that will be absolutely fine. There is no problem with that. Correct. What you need to have, just the output of the final output of your circuit should be this. Okay. So एखाद्याने काय केलं? Suppose they just draw like this. वरचं नाहीये काही. That is also fine. You getting what I'm trying to tell?
Yes, ma'am.
No, ma'am.
Thing which I am telling you is that, see, first of all you have to solve the bracket. That is why you just wrote B OR gate, B C, and there is a OR gate. The output of this OR gate will be B plus C. Am I right? Now what I need to add to
Yes.
that? I need to add A. Correct? So A will be my next variable here. This output is there also. The output of this point is what? Your B plus C. This is my A. Correct? Again there is a OR gate here, and this is my final output. Instead of drawing this in upper side, you can draw it on lower side. This is what I need to tell you. Understand?
Okay, ma'am.
Yes, ma'am. Yes.
Good. So Everyone understand this law of association?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next is the multiplicative law of association. Now see, the, the thing which we did here, the same we have to do for the multiplicative law of association.
Multiplication.
It's just that instead of addition, we are going to put the multiplication sign. And the second difference will be what?
Gate.
We will use
And
and
gate.
Correct. So instead of using OR gate, we have to use,
And gate.
right, instead of OR gate, we have to use AND gate. It's the simple thing. Again, you have to solve the bracket first, A dot B. For this, I can have one AND gate, A, B, AND gate. The output of this AND gate will be A dot B, right? I have to multiply C with that. So what will I do? The C will be my next variable. I will multiply them by using a single AND gate and final output. Understand?
yes,
Yes,
ma'am.
ma'am.
Correct. And the second
Yes, ma'am.
logic diagram is, see, how to implement this. Tell me quick.
First, we will solve the bracket.
First, we will
Right.
solve the
B.
bracket and then we have to take A.
Right. How to solve bracket first? Like, what
B
will be your
into C
first step?
taking,
We to say
Yeah.
like we have to take two inputs, B and C.
Hmm.
Then we will get the answer B
then
into
we will
C.
get the output.
Correct.
After that, we will come multiply it by A and then we will get the final answer.
Right. Absolutely right. So I think everyone is clear with this, right?
Yes, ma'am.
You have
Yes,
to
ma'am.
remember all these law. Okay. Next one is your law of distribution. The first lecture is over, I guess. Okay, so it may automatically add it. Fine. The next one is your law of distribution. What is that law of distribution? The distributive law of three variables is written as follows. How? See, A, there is no sign in between. What does that indicate? Which sign is there by default?
Multiplication.
Multiplication.
Correct. So A, there is a multiplication in bracket B plus C. Now, as you can see here, in a single equation, you have multiplication as well as addition, both the rules. Correct. Now, while drawing the diagram, you have to consider both. To solve this bracket first, which gate I need to use?
First, we will use OR.
First, we will use OR gate. Why? Because we have to solve the bracket first. In bracket,
Addition.
there is a addition operation. So for addition, I'll use OR gate. What
OR
is that?
gate.
B plus C.
B plus C.
Correct. So I'm getting this.
Yes.
Now I have to multiply this entire thing. So I have to multiply this
With A.
entire bracket with A.
With
So for
A.
multiplication, I have my AND gate. Correct.
AND
So
gate.
this entire thing and A. So this is what is my final output. Right?
Yes, ma'am.
Getting?
Yes, ma'am.
Yes.
Yes, ma'am.
Now see the equivalent circuit of that gate, how to solve it. Now see, if I just simplify this circuit, how to simplify? A is going to get multiplied with B. So that will be AB. Yes?
Yes.
Simple maths. AB, which is the sign in between? Plus.
Plus.
I'll just put this plus as it is. Now A will get multiplied with C. What it will be? AC.
AC.
Correct?
C.
AC.
Everyone understand the simplification?
Yes,
Yes,
ma'am.
Yes, ma'am.
Good.
Yes, ma'am.
Now we have to implement a logic diagram for this equation. How to implement that? Now there is no bracket. So what you can do is you can just do with the first step, AB. So what is the relation between A and B? What is the bond or what is the connection between A and B here?
Multiplication.
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 So
Multiplication.
what should I do?
AND
OR
gate.
gate.
AND gate.
Now
AND gate.
OR gate.
AND gate. AND
AND
gate.
gate.
AND gate. Correct. So I'll simply draw a single AND gate. Input to that AND gate will be A and B.
B.
Correct. Output of that AND gate will be AB. Multiplication. Simple.
Yes, ma'am.
Yes.
Yes, ma'am.
Now, what is the next
Yes,
term I
ma'am.
have to implement?
AC.
AC.
AC. Again, which gate?
AND gate.
AND gate. See here. AND gate is there. What is the input to that AND gate? A and C. But I already use A.